was less than that p-value because you can't find it on the chart. It's off the chart.
This is smaller number than this one, right?
So you
Oh,
don't
yeah.
do it like this, you just
So
go
this
where
one
they
bigger?
close, it
So it's
closes,
even smaller than this one.
Mhm.
Yeah.
you just let it
So
go
maybe
like that, or you close, you choose the closest number to
Instead of 0.0.
3.99, 3 point,
Yeah.
So then 3,
That's why I said
write
the
out
p-value
in
0.01
complete
is
sentence.
less than.
So you did this one,
Oh,
complete
I
sentence.
have.
That part confused me too, because I was like, it's not
Very
okay at
long
all.
problem.
So,
What's the same one?
Same one. So,
so you find the value in here and then look for the top here. But then how do you, for the,
you compare.
yeah, degree of freedom, do you put that into, you know, to get the, well, I think, we got the p-value, I mean, you got the p-value, but in order to find it on the chart, you have to look at the degree of freedom to
Yeah,
get,
the degree of freedom is 74, 75.
so 76, yeah, minus 1, so if it's only 4,
yeah, but if you,
then you come all the way down
So
here.
you come to 74, right? And then you look up the t-value, which is 3.22, right?
Yes,
So 3.22, we go to 74, and 3.22 is to the left side, right?
yes.
It's missing. This is the highest value we have. So we use this as the highest value,
2.6.
and we go up and read the probability, 0.01. Now, since we're really to the left of it, it's going to be less than that. It's going to be less than that. The chart's not good enough to go that far. So we know it's less than 0.01. That's all we know.
oh, that's where the degrees of freedom come in. So you have to look at it on this side, and then you see this number, and it's bigger than that, so it's smaller.
Yeah, this table's going down in that direction.
It's my problem, and it's still very confusing.
And it's the easiest one there.
Yeah.
Triola's problems tend to be crisper, clearer, and shorter. Triola actually has problems that are not nearly as confusing as Ilkowski's problems.
And that's the book that we don't have, right?
That's a $180 book that we don't have, no. And if it wasn't a copyright violation, I wouldn't mind copying his problems and giving them to you, but lawyers might get a hold of it. So we have to go with what we got. But this is just how you do the problems. That's exactly how you do them.
So for this problem, the t-test kind of equivalents to the p-test, it just depends on what value you put down here, right?
Yes, it's totally equivalent. But to get the, let's see, should we do it by the t-test, just for example?
Oh.
Okay, so we have the we have the t of our sample value is 3.229. Let's just do it down here. This is the t of your sample. It's right over here.
T-test, so that I can label which one
Well,
is
it's the
what.
same, because you found the t. Let's see if we have to clear the room. I think we do.
Oh, yeah.
There's
There is
the
a
people outside.
plus.
Hi, James. Using this door? Well, no, we don't have to clear the room yet. So this is the, this is the T for your, this is the T for your sample, right? So write T sample equals T sample equals 3.299. Now let's take your T table. Table, and now we're going to look up 0.05 for 74. So find 0.05 in a one-tailed test, 0.05 for 74. And now here, again, we have 70 or 80, so we'll just go right between them. So can you go right between them? This is .05 for a one-tailed test, right?
Yeah.
This is a two-tailed test, so .05 for a two-tailed test, right? So tell me what you get for 74, 75. 1.99? 0.99. So T, yeah, T of .05 is 1.99.
T of 0.5 equals 1.99.
Good. That's enough. Because now, are you in the reject zone?
Yes.
You're in the reject zone, agreed? So next, do you see why you're in the reject zone? Okay. So let me draw here.
Would it still be less than?
Yeah, you did it backwards.
Yeah.
Okay, so now these are your reject zones, right? Reject. And reject, right? And this is .025 and .025 as far as P goes, right? P alpha over 2. But this T value, T here is .199. Now you take a test sample, and here is your test. T test equals 3.29, right? So your test point, is it in the reject zone? Yes. Because this is the t-value of the border of your reject zone. This is the border of your reject zone. Anything with a higher t-value is in the reject zone. So you find the t-value for the border of your reject zone, and you find the t-value of your test. And if your t-value for your test is in the reject zone, then you reject. So you can either do it by comparing p-values, or you can do it by comparing t-values. Same result, same answer. Hi, yes, we clear the room now, guys.
Tomorrow.
Okay, sorry to be late.
Come see tomorrow?
Yes.
Okay.
What,
See you
That's all right.
tomorrow. Sorry.
Hi. Sorry, I didn't understand your name.